continuing on in Chapter 4, starting on Section 4.3. In a previous lecture, we talked about energy flow in ecosystems. And so now in this lecture, we're going to focus on how matter flows between ecosystems or different parts of an ecosystem. So objectives: explain how matter flows between trophic levels and among ecosystems. Today we're going to focus on the water cycle and how it affects organisms globally. And then we'll talk about one of the main nutrient cycles, in this case carbon. And then tomorrow, not tomorrow because there's no school tomorrow, on Tuesday we'll wrap up Chapter 4 and talk about the nitrogen and phosphorus cycle, and then nutrient availability and how that affects primary productivity. So cycling in matter is all about cycles of matter. We have multiple biogeochemical cycles. So if we break this word down, bio means life, geo, earth, chemical, chemicals. So basically chemicals flowing through life, through earth in a repeating cycle. So matter is going to flow from one trophic level to the other. Elements are going to be recycled within and among the ecosystems as well as the cycles. And so your book here lists, this is not from your book, but we're going to talk about the carbon cycle and the water cycle today. And then on Tuesday, May 5th, we'll talk about the phosphorus cycle and the nitrogen cycle in the next lecture. All right, so this is showing how energy flows, or this diagram is representing how energy flows through, or nutrients are recycled through, biogeochemical cycles. These cycles are powered usually by a one-way flow of energy through the biosphere, very similar to this water power in a mill's water wheel. Okay, so they're just trying to come up with an analogy for this. But there are many processes involved in each of these biogeochemical cycles. We have a biological component, which means any activity performed by living things, photosynthesis in plants, eating, cellular respiration. We also have geological processes like volcanic eruptions, the formation and breakdown of rock, like the rock cycle, right? I'm sure you guys remember 8th grade, the songs of the rock cycle. Another process we have is the physical and chemical processes, cloud formation, precipitation, maybe some chemical breakdown. And then finally, the human component, human activities. How do we affect the processes or the biogeochemical cycle? Mining, the burning of fossil fuels, the cutting down of trees, the application of fertilizers, and so on and so forth. Even farming changes the cycle a little bit. Okay, so all right, this is a diagram we have seen before in our previous chapter. Remember that the 4 categories of global processes carry atoms through the biosphere, denoted in green, atmosphere in blue, the hydrosphere in this darker blue, and then the geosphere over here in brown. And these processes are represented in this understanding global change model where, yes, causes of global change can be natural, but then they can be caused by humans. So this is the human realm, and this is by non-human causes. Okay, but everything's pretty much connected to each other. So like if I just quickly talk about the water cycle here. Water cycle, we have evaporation and precipitation, and it could fall onto the ground and go into the groundwater and run off into an ocean. So notice that it involves lots of organisms here. I mean, I could have water fell down to a lake and a deer drank from the lake, and then the deer died and decomposed and back to the geosphere. So there we go. But anyways, here's our water cycle. Okay, so our water cycle can include all 4 spheres, and it has these major processes right here. So if we just start with maybe evaporation. Okay, so water gets evaporated from maybe a large body of water, and now we're into the atmosphere. We have water vapor in clouds, they condense, okay? And when they condense and get heavy enough, then they fall to the earth as the form of precipitation. That could be rain, snow, sleet, hail, whatever. But anyways, they fall, and then it could hit the surface and, maybe travel in a river to a large body of water, or maybe get trapped in the groundwater where it can stay there for a long period of time. or be drawn up by a well or whatever, but this is the water cycle right here. Now, transpiration is when plants take up the water and then it evaporates from the stomata. So water vapor escapes from the stomata. That's transpiration. Okay. All right. Moving on to nutrient cycles. Nutrient cycles, well, what is a nutrient? Elements that organisms need to sustain life. And so I'm going to focus in on the carbon cycle today, and then we'll focus in on the other two tomorrow. So the carbon cycle is a major component of organic compounds. Remember our 4 macromolecules of life: carbohydrates, lipids, proteins, nucleic acids. All 4 of those have carbon. Carbon is a key ingredient of living tissue. That, life on Earth has often been described as carbon-based, right? So we have carbon that can take different forms. It's not just plain carbon. We have calcium carbonate, which is usually made from animal skeletons found in like marine fossils, right? We have carbon dioxide in our atmospheres, what we exhale out. There's carbon dioxide gas absorbed in the oceans. But I'm going to try to talk a little bit about each process, okay, like the biological process, the geological process, the chemical, physical process, and finally the human component, because this is a lot to break down. And so we'll just start first off with the biological component here. So across the biosphere, we have plants and algae that remove CO2. So notice this arrow is being pulled down into the plants. So plants are taking CO2 from the atmosphere, and they do return some through respiration, because plants can also do cellular respiration, but a lot of times they take a lot of it out. And these carbohydrates get passed to primary producers, to these heterotrophs down here, where they can be used to build proteins, lipids, and nucleic acids. But then when these organisms die, okay, it's gonna break down in their bodies and releasing carbon as well as a bunch of other nutrients. And primary producers, they can die too, and they can decompose, and sometimes they get transferred into coal deposits or some type of fossil fuel. And over geologic time, these processes remove carbon from the atmosphere, and it's stored in the geosphere. So coal, oil, natural gas are called fossil fuels because it's fossilized organic carbon. Whoops, why did I do that? I don't know. Okay, moving on to geological processes. So carbon dioxide, so we're going to be looking at the green arrow here. Okay, carbon dioxide can be dissolved. So what I mean by that is it's trapped in the oceans. And it's kind of like a soda, a bottle of soda or a can of soda. You open up the bottle and the bubbles are released. Okay, now with our warming temperatures, CO2 gas is being released at a faster rate. But a lot of carbon dioxide is absorbed in the ocean. All right. So anyways, the CO2 that's dissolved in the oceans can combine with calcium and magnesium to form carbonates. And these carbonates accumulate on the bottom here in these marine sediments. They combine with skeletons of marine organisms. They form a large amount of sedimentary rocks, or maybe carbonate rocks over here. And then through geological activity, they can be brought up to the surface, or maybe melted in magma and released as CO2 gas. Okay. Moving on to the chemical physical cycle, CO2 is constantly being exchanged between atmosphere and oceans through physical and chemical processes. So that's kind of a short little loop right there. Anyways, carbon dioxide does make water slightly acidic as it falls to the ground. And then finally, the human impact. So we do extract these fossil fuels and we burn them. We release CO2 gas into the atmosphere. So our CO2 levels have increased. And, I just want to say that current CO2 levels are like, what, 0.03%? So 0.03%. It's greater because of humans, but I think people just need to kind of relax a little bit about carbon emissions. But that's my personal. I'm just going to stop right there before I start some type of war online. Anyways, that's all I'm going to cover today. Tomorrow I'm going to talk about nitrogen and phosphorus.